So now we are moving into the k-fold cross-validation, which is basically an extension of the split sample design that we have just seen. In the split sample design, what we had is something like this, right? You had, say, for example, certain portion of the data that was in the training data, and then we had rest of the data as the test data, right? But how do you know if your test data did not have a really high outlier? You know what I mean? So just by random, because these partitions are happening at random. So just because one outlier value that is really extreme value was in the training data, then your model will be built in a certain way that your test data might not be able to handle, and vice versa, right? If your test data had a really high outlier value, obviously that is not going to perform well when you had the model built using the training data. One solution to that is obviously to try repeatedly, because every time you are trying your split sample, you are doing it by random. You could try to do it repeatedly to try to see whether your values that you are getting for R squares are very different when you are doing your repeated sampling different times. Or you could try to do it in a more systematic way, where you from the beginning decide how many times you are going to iterate, right? So for example, you think that, okay, I'm going to just iterate certain number of times, and then I will have one portion of the test data in the first iteration, other portion of the data which was not in the test data in the second iteration, third iteration, fourth iteration, and so on, so that everybody was once in the training data at least, or once in the test data. I just made sure of that, right? If that is the case, then the coding is slightly different for our split sample. In our case, let us just work with one example, and that example is 5-fold cross-validation, where this k is equal to 5, and I'm just trying to do this 5-fold cross-validation. What I'm trying to do here, again, I'm using the caret package's create folds function, and I'm using the length of stay as the observation. I have k equal to k, and I have this determined k equal to 5 already. And then I have list equal to true and return train equal to true and all that. Those are the other parameters. Just to make sure we are getting the right amount of numbers, you see the 1/5 of the data set is 1100, and 4/5 of the data set is like 4500 or something like that. And when we check the first fold, 4588, 4588 exactly true, and 1147, 11. So the rest will be obviously the 1147. But in the fold 5, you can see 4587. So first fold and the fifth fold has slightly different number of observations, but that's all you expect when you are dealing with random sampling, and there are some proportions that are going on in the scenario. Okay, so in practice, you do not really have to go through all of these steps, but I just wanted to show you what happens in each of these folds so that you get a better understanding. Generally speaking, caret can handle all of this all at once, so that you do not have to worry about building model and testing model at each of these steps. So in each of these steps, what I'm basically doing is that I'm trying to set the first folds training and first folds test data. I'm just dealing with one iteration, right? I'm not worried about the other iterations. All I'm doing is that I'm using the fold one's training data to build my model, and then I'm using the fold one's test data to make the prediction, and I'm using the performance function that I have wrote, and I'm getting certain number of R square, adjusted R square, and root mean squared error. In the fold 2, I am again doing the same thing. In the fold 2, I am building the model using the fold 2's data, and then I am using the fold 2's data to get the test data and doing the model building and performance. So again, I'm getting some sort of R square value, adjusted R square, and mean square R square. The problem now begins. I have 5 folds now. I have 5 R square values now. I have 5 adjusted R square values now, and stuff like that. What do we do? I simply average them out. to get my R-square value out of this cross-validation, right? Okay, so you could do that. You could do that by hand, or you could simply use the caret package to do all of these things for you. So in here, and this is a very basic framework that you will be repeatedly using, whatever machine learning method you are going to use, you are just going to change the name of the method. Everything else will probably remain the same. Yes. Okay. Set seed is something, remember, like when we are doing the sample splitting for the test set and the training set, we're doing it at random. So that like there is no way the analyst determines who goes in the training and test. Set seed is going to determine who goes where. So that if you do your analysis one time in your computer, and in the second time you do it, you will never get the results unless you set the seed, right? This is a way to make sure that your results are reproducible, at least in your own computer. But one thing I should warn you is that, say, for example, in my, say, for example, Mac, if I set the seed to something, and if, say, for example, someone else uses a Unix machine and they set the seed to some other same seed, both might not get same results. Right? So sometimes seed is system dependent. That's all I'm saying. But if you are running this analysis using this seed, and then you are using again this seed to run the analysis again, you will get exactly the same result. First thing first. So obviously, cross-validation is not the only method by which we can address this overfitting problem. There are other methods, right? So there is cross-validation. There are some extensions of cross-validation. It is known as the repeated cross-validations and all that. There are other methods known as bootstrap. So there are many methods that are available for this overfitting adjustment. So in here, within the train control, you need to specify which method you are using. I'm basically using a very raw version of the CV method, and I'm specifying what is the value of my K. So in my K for cross-validation, that's all I'm defining here. And then once I define my train control, I basically, within the train function, I specify what is the train control. What is my data? See, this is the full data. This is not the training or test data. Once I specify the training control, caret will do that automatically on its own. And then I simply specify the method, which method I'm going to use. So for example, remember in our example, since we were dealing with continuous outcome, we basically use the LM function, right? That's exactly what we are mentioning here. See, this is just a 2-line code, nothing else. You don't have to do all of this crazy stuff. And this will give you this output like this. Let me try to read this output. So basically you are using linear regression, how many samples you have used, how many predictors you have used, and then I could, if I wanted, I could do some pre-processing on the analytic data. And I will show you one example of what those pre-processing is. In terms of the resampling or the process by which I'm addressing the overfitting problem, I'm using the cross-validation 5-fold. Summary of the sample sizes, and these are the summary of the sample sizes. See, so this was the training set, this was the training set, dimensions, right? And then resampling results. This RMSE is basically, there were 5 different RMSEs from these samples that were coming from the test data. These are the training data, by the way. From the test data, there were 5 different RMSEs you were getting. This is just an average of those. R-square, this is just an average. MAI, this is some other measure. This is just an average. And in our example was so simple, there was no tuning parameter that we were testing against. So there was no tuning parameter here. Otherwise, if you had any tuning parameter, it would say that this parameter is the best parameter out of all of the training grid that we have used. Okay. So, okay. But I want to see what was going on in each of these folds, right? So these are the RMSE for each of the test data. RMSE for the R-square for each of the test data and stuff like that. And it exactly tells you from which folds you are getting these results. Okay. And then if you take the mean, you will simply get the same mean that was reported in the original output. You can also try to calculate the standard deviation. RMSE and stuff like that. So this is one of the major objectives of this today's class is for me to explain you what is the problem of overfitting, what are the ways you can address overfitting. And I have showed you two examples. One is sample splitting, another was the cross validation. And I showed you how to do the cross validation by hand and how to do the cross validation using the caret package using the two lines. One thing I can say that you were here in this class expecting to learn about machine learning, but all I'm talking about the linear model, right? But I can assure you, since you already know the caret package and the functionality of it, you simply need to change the method's name from linear model to some fancy machine learning model's name. And I'm going to get to that, but I just wanted to clarify that we are on track.